The person whose username is user needs to tell me who they are at this point because...
It's Stevie.
Oh, okay, very good. Can you guys put some identifiable names, first of all, for the attendance purposes? And also so that I don't remove you by, because I don't know who you are. Okay. So please put that as much as possible because I'm going to put this in the attendance. And same thing goes for Mina. I think I know who that is. Okay. Okay, so welcome to this class today. And we're going to do something a little different today. Basically, we're going to prepare ourselves for the exam mainly. We're going to talk about the exam and how it looks like. And we're also going to talk about the project. I think there was a question. I need to answer that question quickly. Some of you probably have already, let me check quickly to see if that's done or not. Okay. Oh man, still asking about this. Hold on, let me send a quick, because somebody's having difficulties joining us, and it's the person who actually asked the question about the this conversation. Okay. One more thing, I'm trying to checking to see if some people have already submitted the project. Silence. Motion. Okay, yes. Yes, one person did. So let me go back into the okay. Julian, and I don't see him in here, but again, you guys can always go and check the recordings later on YouTube. Please do subscribe there so that if there is any postings, you're aware of when they come in exactly from YouTube, so that you will be notified about them, because I've been posting a lot of materials lately on YouTube, and sometimes it gets tiring to every time I post something to go and locate the class I'm supposed to post it on, and then post a link there for each video. So I'd rather have you guys go there and put your subscription so that you will be notified. That way it saves a little bit of time for both me and you, in a sense that you will be notified immediately about the content that has been uploaded. That way you don't wait for me if it's of interest to you, if it's related to your class. I know a lot of them are not probably related to your class, and that goes around for all the classes. But if something is, probably you'll have access directly to it. And the other thing also is that saves me time so that I can be working on something else. Okay. Of course, you know, guys, that we've been doing chapters 1 through 6, and that is exam 1. And exam 1 covers basically half the course, so we're midway there. Okay. Okay, so I have okay, so that's important, and from this point on, we're going to start chapter 7, and this is really what astronomy starts, honestly, in terms of stuff that is related to the solar system, because so far from chapters 1 all the way to chapter 6 were really tools and the history of astronomy and tools used by astronomers trying to study the things in the sky, whether it be the solar system or beyond the solar system. And so this is exam 1. Exam 2, again, is going to be later on. And for those who came a little later, and I guess I'm going to post this one on Canvas to make sure that everybody's aware of it. Spring break has already been consumed because of the fact that the school stopped because of the transition going through the online thing. And because we have a requirement to meet a certain number of instructional times, instructional hours that we have to fulfill, that's why basically they're saying we are going to basically continue through the spring break. Besides, we're not going anywhere now under this basically stay-at-home order. So basically, at least you have something to do while you're sitting at home and hopefully weathering this out. There was a question, like I said, related to the project. So let me go through it quickly. I know a lot of you did not submit it. And if there is any other question related to the project, please ask it right now, because I don't think that I will be coming back to this project again, because we have another project that we need to start working on. And the question, Andrea, please remind me by email to send you. It's really a lot easier than this one in terms of content, but send me a reminder to send you again the content to look at it for the second project. Okay. So the question is related to, so let me share my screen quickly, but let me find the file again first. I believe this is the one. So, okay, so the question is related to the project, and the question is basically what asked is when we're doing the last question, let me try to find it again, because that's probably not the, it's actually the response form that needs to be shared. So let me open that. Did I publish it to you guys in a fillable format or not? I need to know, because I may have forgotten in the mix of doing other things, especially for other classes and recordings and for your class and everything else. Okay, let me check since I'm here. Let me go to your class, because the one I just popped up open is not really the one that should be the fillable form, basically. It's not fillable, basically. It's just a plain old PDF file. Oh, it's not. When is this project due?
Friday.
Friday. I think I need to work on it tonight. Somebody has to remind me about it to give you the form in fillable format. I know there are some parts that you cannot do by hand, even though, I mean, you cannot do by, you cannot fill really, but we'll have to do it. I'll have to publish the fillable version of this, because I just noticed that basically, and if I say something, please hold me to it. If I promised, and I don't remember honestly if I did, and I think I did probably, I don't remember when, that we need to have this one in a fillable format. And please do remind me if you don't see it immediately when it's supposed to be, hey, we didn't get this this thing that you said that we're supposed to have about this file or that file or something like that. Otherwise, I mean, there are so many things happening now. Sometimes people, and I do forget. I don't know about people, but I do forget. So, okay. So let me change the file and go to this one in here. So let me stop sharing the other file and get you the proper PDF file. It's this one. This is the shareable file that basically that we're supposed to be working off of. The objective is the objective of everything in here is basically to track and try to explain the retrograde motion of Mars, and not just of Mars, actually, or a lot of the all of the planets that we see, and some of things that are not even planets, basically. And but we're taking Mars as our basically because Mars the motion of Mars is very easy to see. And I understand now why probably doing it fillable is not going to gain a lot, because you have to draw this graph by hand, so you can't really. So it's kind of I will do it for you guys, but it's still probably you'll have to do this graph, and you cannot do this graph by. I think we did last time, and we tied it with PDF file, but we will try. We will see. I'll get you the fillable version of it. And you're going to answer the questions in here. All you have to do in here is read the instructions. It should have the answers in there, or the book. If you still have questions, please be specific. Ask, okay, what is meant by question 1? And when you do ask it in the discussion session. That way everybody sees the question. And if I don't get the time to, to look at it, somebody else might, okay? And they might answer it. And that's how you enrich the topic. That's how you make it richer, actually, by having a lot of people in it. So it's not just me. And then question 2, what is the meaning of the term retrograde? Again, the definition should be in the instructions. And about what time did Mars retrograde? And this is, you can see it from the graph in here, when it starts to go back, okay? And then when it's going to move forward again, but what time the day did Mars retrograde, move back to where it's supposed to be moving? And the conclusion basically on this one, you're gonna put some specific dates. You say in here, hey, it's the Mars from based on the data and the graph that we have in here, it started to move backwards on this and such date and move forward and such, continue moving towards supposed to be on such date. Try to keep it simple. Don't have to complicate it a lot, okay? Just basically focus on the data that you have and the answer questions that you have and connect those directly to those. So you can just basically rephrase what you have just answered on those questions. And then in here, you're exploring 2 models basically for the retrograde. One of them is the heliocentric model, where the sun is in the center of the solar system, and the geocentric model, where the Earth is in the solar system, and trying to explain the retrograde motion of Mars, okay? And so that's basically the objective. There are 2 circles in here. So again, you read the instructions and you should be able to answer question 4. And question 5 in here, basically in the geocentric model, the retrograde motion of the planet is it real or an illusion? Of course, you're gonna be able to tell. Okay, and you do the connections in here, and you will see where they line up. And in the heliocentric model, again, you're going to answer the same questions. Is this an illusion or a real thing? You do the connection in here, and see at some point the planet Mars is going to appear to be moving backwards. And ancient philosophers would argue that the heliocentric model stating that they did not feel the Earth moving. As what is wrong with this argument? Again, because it's really the radius of the Earth is so big around the sun, you cannot move it. You cannot. Besides, you're moving with reference frame anyway. And the conclusion is was actually explain the retrograde motion of Mars, but one of them is real and one of them is not. So basically, that's in a nutshell what the conclusion of this part is. Retrograde motion of other celestial objects. In here, we're going to explore based on the data that we have, how other objects experience this phenomenon, which is the position of the exterior planets like Mars, Jupiter, midway in the retrograde motion. You can look at the instructions and you can answer this question. Basically, in the instructions, let me see if I can pull it quickly here. Okay, for it's the opposition or the inferior conjunction. That's one of the 2 for the inner ones, or the conjunction for the basically either opposition conjunction or superior conjunction and inferior conjunction for the inner planets. So those are the questions, how they are related. Again, if you have any specific questions, please do so. Mercury, Venus, orbit. So basically all of these questions are the inner planets. And now you have this table to fill. This table relies on calculations that hopefully you guys have seen a sample of it last time around. And if you have difficulty, please do not hesitate to ask. I don't want you to be stuck looking at this table in here and not being able to progress. I mean, I'd like you to make progress on this thing, no matter what. This is not an exam. This is something you're supposed to be working on. You're going to be doing it. Hopefully you do it right, and that's really the bottom line. First you do it, second you do it right. So if you can't do it right, please let me know, talk to Andrea so that we can move on this thing. It's not, there is no shame in not knowing something, but there is a lot of shame in not asking about it. So you really have to ask questions. Do not be basically looking at it and I don't understand how to do this or that. Okay, every single one of them is don't hesitate to ask about any part. The question again about the results, that's the question of Julian, basically the one that I'm answering them, is about what am I going to talk in here about the results. And then here, on the models of the heliocentric model, we were able to basically, we divide the inner and outer planets and we can predict when the next retrograde motion will occur, the next occurrence, basically. You can just simply as it relates to what you did. in general in here, this we can always, I mean, what they're saying in here is the objective of the entire project was to study the retrograde motion of planets and actually solar objects, not just planets, using Mars as a model. And here we were able to distinguish the different position of the planets with respect to the Earth and when, as far as they're concerned in the solar system, and we were able to predict their next occurrences. For example, and you can cite the example, the typical example you would like to talk about usually either Mars or Venus because they are closest neighbors in terms of the more significant that you can observe these things with, especially Mars in here, okay? So that's in a nutshell the project. Any other question about the project? No? Okay. So like I said, we're done with the chapters. I think I uploaded all of the content for you guys in terms of the notes, in terms of everything. So you should be able to prepare yourselves for the exam. The exam, basically the format for it is the following. Thursday, I will post the review session for the exam. Okay, for M, where is the graph? I don't understand. Brandon is asking for the graph one, we just have to follow the formula. Which graph? Okay, let me go back into the PDF file to make sure I know what we're talking about. Oh, I remember now. Okay, no. Brandon, can you tell me exactly which graph are we talking about? Hold on, Alexis, let me answer a question for Brandon. Can you, Brandon, elaborate on this graph, which one you're talking about? Because it says for the graph one, we just follow the formula provided to get M, correct? What is M? What do you mean by M in here? You can turn on the microphone if something too long to type, okay? Brandon. Oh, yes, okay. Yeah, for S, yes, just follow the formula, basically. Yeah, okay. So okay, so let me go back into that formula because it's important to me. So I'm going to share the other PDF file. It's this one in here. So in order to find S in here, because you need S in this graph in here, in all of this table in here, for all of these planets in here. So S in here is going to be, in month, of course, you take the period. For example, I did the example for Mercury, which is 2.89 times T for Earth, which is 12, okay? I'm sorry, T for Earth, which is 12, times T for Mercury, which is 2.9. It doesn't matter the order of operation here because at the end the multiplication is commutative, so you can switch, it's fine. So anyway, bottom line is 12 times 2.89 divided by 12 minus 2.89. The number is going to be positive, so you keep it positive. You plug it in here, whatever you get from that calculator. Same thing, you take 7.38 for Venus, you multiply it by 12, and you divide it by 12, subtracted from it 7.38. Whatever the calculator gives you, you leave it as is. You don't worry about it, and you plug it in here for Venus. For Mars, though, you're going to do, again, 12 for Earth, times 22.6 for Mars, and you divide it by 12 minus 22.6. Of course, you're going to get a negative number now, because 12 is less than 22. So what you do in this case, you don't put a negative number in here, put a positive. You remove the sign, basically. Whatever the calculator tells you, remove the sign. Don't try the sign. So in this case in here, it's going to be a number that is always positive. For this 2, it's going to be a positive according to this formula straight out. For this 4, there's going to be a negative number if you don't include the absolute value. And the absolute value basically is telling you remove the sign. That's all. Okay? So remove the sign in here. And again, for series, what you do in this case, you take again 12, you multiply it by 55.2. It's 55 months for it to go once around the sun. And you divide it by 12 minus 55.2. Again, it's going to be a negative number. You ignore the negative sign in here. And for Jupiter, it's going to be again 12 times 142 divided by 12 minus 142. The calculator is going to give you a negative number. You ignore the negative number and you plug it in here. And the same thing goes for Saturn. Again, you're going to get 12 times 356 divided by 12 minus 356, and you plug in the number in here. So all of these numbers basically are coming from this formula. If I understood the question from Brandon. And now here requires a little bit of thinking. Basically, the first occurrence this year was February 26th. We add this many months, this many days, basically, what is it? This many months, I'm sorry. Did I add them in days the other day? I think I made a mistake. No. Yeah, that was correct, okay. I don't remember the calculation in here, but you add months to this thing. Did we get a 3 or something in here? I don't remember what we found in here for this planet. Let's make sure. I don't want you guys to get the wrong answer. Okay, I'm going to pull my calculator in here. Actually, let me stop that one quickly to show you how the calculation is done with using my calculator in here. So again, I'm going to share with you the calculator now. Okay, so the formula in here says take 12 for the Earth. There is 12 for the Earth times what is it? 2.89 for okay, this thing is in the way in here. Okay, 2.89. Okay, divided by 12 minus 2.89 and close the parentheses. So this is how my calculator works in here. This is Microsoft Mathematics. So yeah, this is gave me 3 months and 0.81. So the calculation we did last time was correct. So it's 3 months and 8/10 basically, or 0.80 or 81% of a month. So what you do in this case, you add 3 months to February. So it's going to be the first month of February. After February is March, April, May, and then you add an 81% of a month. 81% of a month, which is 0.81 times 30 days, basically. And that's going to be 24 days. You don't care about the third of a day, okay? So the next occurrence is going to be not March 26th, not April 26th, not May 26th, but 24 days thereafter, not a full month, but 24 days after that. So you start counting until you find the date when this one comes in. So that's how basically you do it. So let me, I think I need to stop this. Okay. So you come in here, let me go back to the sharing of this table in here. So you come in here and you add 3 months and 8/10 of a month, or 0.81% of a month, to be more specific, and you get the number. So that's how you find the next occurrence. You predict it basically. So that's some of the powerful stuff using the Newtonian mechanics, is that you can make predictions. Okay, and like my bold story, remember the story we talked about in the class about the non-scientific models? You can predict things. Okay, so that's you make it in here. I see another question. Hold on, okay, guys. I know I'm coming to this question. Same thing for Venus. Let's do Venus to make sure that we have it fully understood, okay? So for Venus, it's 7.38. So basically, what I have in here is let me stop the sharing of the screen to just show you the calculation, how it's carried out. I'm going to pull the calculator again. So 7.38 times 12, so it's 12 times, the time is on this calculator is a dot basically, 7.38 divided by, open parentheses, 12 minus 7.38, and the number is going to be, it's a positive number, so I don't have to worry about it, so it's a good number. So it's 19 months and 16 or 17% of a month. So I'll have to worry first about the month. So I go to my data in here. So this year, it occurs on June 3rd. June 3rd, after 12 months from that, it's going June 3rd, 2020. So the next year, 12 months after that, is going to be June 3rd, 2021. So that's 12 months, but I still have to add 7 months to that because 19 months is 7 months plus 12 months, 12 months a year. So now I have to add 7 months to June, which puts it in July, August, September, October, November, December of 2021, plus January of 2022. So it's January 22, January 3rd, 22 is plus 19% or 16, 17% of a month. 0.17 times 30 days. So plus 5 days. So it's not going to be January 3rd, 2021. I have to add to it 5 days. 5 days added to January 3rd will put it on January 8th, 2021. You see how this calculation is carried out? Just to complete this so that we have a complete picture, I'm going to take series, which is 55.5.2, just to show you where the negative number comes into play in here. So 12 times 55.2 divided by 12 minus 55.2, and the number I plug in here is 15 and a third of a month. Third of the month is easy. It's 10 days. Okay? 15 months plus a third of a year. So this here for series, or at least the next one in series on July 7th. So I have to go year after that, which is put it on July 7th, 2021. That's 1 year, plus 3 months after that, because it's 15 months. So July, after July comes August, September, and then October. October 7th, add to it 10 days, October 17th, 2021. Okay? So the negative number in here doesn't matter. I'm going to put a positive number in the table. Okay? So let me stop sharing in here quickly and see how you guys have a few questions in here. So first of all, Ian, what do we... Okay, I'm coming to that question again. I think I talked about them, but let me... Okay. Okay. Was that BD who was user? Yes? Yeah, I think it was. Anyway, when it's negative, like I said, just ignore the negative sign. Just ignore that negative number. Like for series, for example, it's going to be negative 15.333. So it's just 15.333. Okay, so that's good. Ian answered it. Very good. If we run the numbers and get a different number, what is the... Okay, at least keep 4 significant numbers, but you're going to be off by a day or 2, basically, if you don't round correctly. That's fine, basically. If you predict, for example, it's going to be on January 8th, 2021, but instead you go on January 7th and see the motion is actually started retrograde, or go the day after. It's really, there is a window for it too, basically. You can't really, so that's what you're saying, basically. This year happens on July 7th for series. I'm going to expect it to happen next time around in what did we say, October 17th or something like that of 2021. So again, around that time, around mid-October of 2021, you should be able to see, I mean, you can track it with the naked eye, of course, it's too small, but with the telescope, you can see it actually going back and then starting to move forward. So that's basically how this thing is working, okay? So, okay, so the question again that is persistent, and Ian and actually Julian asked it, so let me clarify this question here once and for all. Let me go back into sharing that, the one for response file. Okay. The project is divided into section 1, which is really looking for retrograde motion of Mars, tracking it on a graph. That's what, based on some given data. That's the objective. We're clear on it? Mapping the data that is given to you for retrograde motion of Mars. That is one thing. And then answering the questions related to that specifically. Here, you have done that. You mapped, you tracked, you also found exactly when, based on the data, when Mars started to go back, and now when it started to move forward. So that answers the question, the objective for that section of the project, and the answer to it. Now, the second part of the project deals with the models for retrograde motion. Now you have two models, geocentric and heliocentric. And here, the objective, we're going to basically look at two different models for the retrograde motion and compare the two. That's the objective. You do the actual activity, you answer the questions based on that. What is the heliocentric? What is the geocentric? Once you answer that and you model it, you come to this part in here and you answer. Based on these two models, both of them explain the retrograde motion of Mars, except one of them is real and one of them is not. Let's answer that one. The third part of the project now is retrograde motion of other objects in the solar system, not just necessarily Mars. Okay, and here you're given that's the objective. You want to study this retrograde motion of different objects. That's not only the Mars that retrograde, but other objects. The overall object, the overall of the project is taking Mars as a model to study the retrograde motion of objects in the solar system. The first two activities are actually related to that question, to Mars, and this one is actually for all the other planets like Mars and Jupiter. There are two different groupings. Of these objects. Some of them are inside they're in the inner parts of the Earth's orbit, and there are two actually, Venus and Mercury, and others are outside of the orbit of the Earth. And there is different terminology for both of them. You're answering the questions and you're answering this specific question to make the predictions. And in here, you were able to basically divide the good objects in the solar system other than Mars into two different groups, inner objects and outer objects, and predict when they're going to basically retrograde based on the data that was given to you and based on the formula that was given to you. The overall conclusion basically is the fact that, look, you took Mars as a model to study the retrograde motion and were able to study the motion of all the objects in the solar system. Okay, not all of them. Many objects in the solar system based on that model, and compare the two, and also based on actually the whole thing, the data that was given to you is a heliocentric data basically on how to do the calculation. Because all of these orbits that were given to you, the period for Mercury, Venus, Earth, Mars, Ceres, Jupiter, and Saturn are all heliocentric data. They're all around the sun. So this study in here at the end is the real one, is the purpose of the whole object. This session is recorded, so hopefully you guys can go later on. If you still have any questions, try to put it in your own words. If you still have any questions, please don't hesitate to ask, because that's basically in a nutshell what the project is all about. Let me go into the chat session here and see if there is more. Okay, so I'll have to stop there. Okay. Ian, does this answer at least your questions?
Yes.
Okay, very good. Okay, everybody else, please, and I know a lot of people are not here today, make sure you follow the plan. Basically, the overall project has a big objective, and the overall project has also a conclusion, okay? And it's divided into 3 sections. Each section has its own objective and its own result. and basically, and has some questions in it. So the whole structure basically is help you go from top to bottom, trying to come up with some sort of an understanding that hopefully you'll pull from this product. That is my goal. That is my objective, so that you guys have an understanding of how this thing is working. Okay? Do not hesitate. Andrea is with us in here. I don't know if you guys have her contact information or not, or you do. If not, let me know or let her know, at least through this session, and she should be able to help too, in case I cannot get into it in time. Okay? Does this sound like a good plan, Alexis? I want to see that thumb up. Okay, very good. Okay. Yeah, and Krista also, very good. Thank you. Okay, so basically, this is one part. The second part of today's lecture, again, we're not starting chapter 7. I will, depending on how it goes with what we're doing today, we probably are going to start it Thursday, or we'll start it after the exam. The exam has been postponed, not this Thursday, but rather on Tuesday. And the format for it, basically, this Thursday, you'll be given the review problems, the review questions, basically. You'll be given a lot of questions, too many to basically count. And the exam will be random, basically pulling from those questions. And the format may change, but basically you have to focus and you have to do the review. If you don't do review, unfortunately, you're not going to do well in the exam. So you have to really do the review questions. And you will have a lot of questions, I think, in the order of about 200 or something of them. But of course, during the exam time, which is supposed to be an hour and 25 minutes, exactly if we are sitting in the classroom, they would be only accounted for as if you're sitting in the classroom and doing this many. So you're not going to get 200 questions basically to answer, because you cannot do 200 questions in an hour and 20 minutes, even if you don't think about them. If you can't do that. So it's going to be a limited number at this point. I didn't decide exactly the number of questions, and I guess it depends also on the strength of those questions. So having that in mind, you will be seeing, like I said, the review questions. The exam will, once the exam basically starts, the review questions stop. So review questions will be available for you guys to work during the entire weekend and all the way to Tuesday morning. By Tuesday morning, the review questions will be not available for you guys to see them. And then after that, the exam starts. Once the exam starts, we'll have only limited time to complete it. And once you start it, you cannot leave to come back and finish it later on. So it's really, you have to really be focused on it, prepare well for it. You should not have difficulty with it. If there is a question that you don't, in the review the exam, you will have the answers, but you'll have to do them at least several times before the answers are revealed to you. You really have to do some honest studying before before going into the exam. You have to look at the materials that we did in class, look at the materials in the book, try to answer the question, move on, try to answer the question, move on. And that gives you at least how well you think you're prepared. You're not going to get grade for it. You're not going to be punished for getting a wrong answer. You're not basically just to help you prepare for the exam. Okay? Once the exam is launched live, once it becomes available, at that point, once you start it, you cannot go somewhere else and basically come back for it trying to finish it, because it will not happen. Once you're done with it, it's going to basically submit whatever you did. Okay? So that's how the exam is going to work out. And hopefully you guys, if you have any questions, especially if the answer doesn't make sense to you, please let me know so that we look at it. Sometimes these things happen too. Okay? So, in preparation for the exam, I prepared a few questions for you guys, and I'm going to launch them. Again, you don't get punished right now if you don't do them. You will only get rewarded for participating, and that is participation grade at this point. So I know that some of you are not here and they're not going to benefit from that. And I know at least a couple of you are sitting together, so both of you are going to get the credit for that. And so I'm going to launch one of the questions, one of the series of questions. I have a lot of them in here. and you're going to be basically going through them. We're going to give you, since there are about 10 questions, I'm going to give you at least 5 minutes on them. Try to answer to the best of your abilities the correct answer, and then we'll discuss the correct answer, and then we'll move on to the next one. Does this sound like a good plan? Teresa?
Yes.
Okay, very good. Okay, so if you don't see the polls, it's probably because maybe there is something that is blocking it in your computer. So we need to fix that. But if you don't see the polls, please let me know in the chat underneath that you cannot see the polls. Okay, it's going to be launched now. And good luck. I'm watching the results. So once you answer all of them, it should pop up in here that you're done. So Sheridan is having a problem. Alexis also is having a problem. Okay, if you don't have popped up, and I know two of you are having difficulty with it, put a text file, please, and start answering the questions. Okay. And once you're done with answering the questions, just put A, B, C, D on the question 1, question 2, question 3. Once it's done, before we start doing the questions, please send them to me. You don't have to send them through the chat session. You can send them email, or you can send them through Canvas.
Sorry, can you repeat that?
Okay, if you don't have the polls up and running, I know two of you are having difficulty with this. Answer these questions, okay, on a piece of paper, on a chat, you know, on a notepad or something, okay? So here, let me share quickly I don't want to share it. Open a notepad, put Q1, and then the answer is A or B or C, whatever. Q2, the answer is whatever. Oh, you don't have that. I'm sorry, just talking nonsense. Yeah. Never mind. Okay. You can't see that chat at all? Okay. Okay, I'm taking note of this chat anyway. So you're going to get participation quiz after that, okay? Participation grade.
Thank you.
Okay, for both of you. Okay, I have one person who locked in the answer. I need you all to participate. Like I said, there is no thing wrong with having to answer. Just if you can't get the correct answer, just guess. Two people locked in their answers. The quiz has been up for 4 minutes, so we really need to give it another minute, maybe. 3 people. Okay, we're going to give it 30 seconds, okay, for you guys to finish it, okay? I know some of you did already. Okay, 10 seconds, and I'm going to end the polling. 5 seconds. Okay, and the polling is ended now. Okay, so you guys still see it or not? Okay, I'm going to share the results with you so that you can see it, okay? Of course, it doesn't have names, so you guys don't have to worry about the... Okay, at which of the following location on Earth is the direction we call east, not clearly defined? It seems 3 people think that it's the North Pole. And why is that? Can anybody tell me why is that? The correct answer is the North Pole, of course.
Because the east basically goes around in a circle at the North Pole.
Yeah, because when you are on the North Pole, I mean, first of all, let's eliminate the obvious one. It's not Greenwich time because that's Greenwich line that determines the east and west. It's not the U.S. coast, which is kind of funny, basically. If you go on the East Coast, there is no east. I mean, there is still east on the other side. The equator is not possible. I'm glad nobody picked it up. The International Day timeline is basically that determines day, I mean, what day it is. Is it today or tomorrow? That's not possible. But when you are standing on the North Pole, any direction is actually east to you because you are really in there. But you move anywhere outside of it, then there is an east and there is a west to you. So that's basically the correct answer. Okay, the number of degrees of arc that your location is north or south of the equator is called, that is the latitude. That's correct. Yes, most of you got that correct. The prime meridian where the longitude equals 0 passes through. I hope, okay, I'm glad nobody picked the Peninsula Cucamonga. I put it in there just to make sure that we have something local in here. Okay, it's called Greenwich actually. So the correct answer is where most of you thought it was, okay? It's not in the Pacific Ocean away from all land. This is the Greenwich basically time. That's what they call it, basically the center of the thing. Okay, in locating objects on the celestial objects, we call the degrees east-west or something from Greenwich. Yes, the correct answer, most of you guys correct. It's the longitude. The latitude is north to south, and the longitude is east-west, basically. Declination is for the objects, and that's actually the equivalent of the latitude that are in the celestial sphere. Typical astronomers express right ascension of a star on the sky in what units? Most of you get that correct. It's hours, minutes, and seconds. Remember an hour? Wait a minute. Yeah. Basically, you can eliminate the obvious one. It's not kilometers. It's not light years. It's not meters squared. It's not a distance at all. Okay? So typically expressed, so this has to be something which is this one. Okay, so it's the hours and minutes. Actually, the project has the right ascension for Mars. All of it is expressed in hours and minutes. Okay, so that's basically the number that you have in there. Okay, if you want to locate someone precisely on the Earth of the, you specify the exact latitude and longitude. If you want to locate a star precisely on the sky, you need to specify its So things on the Earth are with the latitude and longitude. When you map that onto the sky, the vast majority of you get this one correct, and that is the RA and the declination. Okay. The latitude of the Earth with respect to that must be 0. That is the starting point. Anything above it is positive or north. Anything below it is south or negative. And it's a positive 90 going all the way to the North Pole, and going to the South Pole is a negative 90 or 90 south. Okay? So most of you got that one correct too. What would you have to change about the Earth to stop our planet from having significant different seasons? Most of you got also this one correct. The distance from the Earth to the Sun, and that is sometimes people get that one also confused, is not really going to make a significant. You see here the question, significant different seasons. The key for significant is the tilt of the axis, and that's correct. Most of you got that one correct. The new age bride and groom who are enchanted by the sun want to get married on the day when it gets the highest, when the sun gets in the highest of the year. You live in the United States. What day would that be? And of course, that's going to be the summer solstice. Most of you also got that one. That's correct. That's the longest day. So they want that day to be memorable. So they want to have it as long as possible. Okay, to enjoy it as much as possible. In Australia, in the southern hemisphere, when are the days the shortest and the nights the longest? Okay, and this also can be confusing a little bit because the days are shortest and the nights are longest. That means it's their winter time, and the correct answer, you guys, most of you get it correct, which is in late June. Okay, so you ready for another one? Yes? Okay. This is the same one. It's not letting me pull another one. No, not this one. Yeah. Let me get from another chapter. That was from chapter, I just want to make sure I cover enough material from at least today. So let me go to chapter 5 right now. Okay. So these are a different set of questions again. You have 10 of them. You don't see it?
Now I see it.
Okay, what happened? I thought, okay, good. Okay, Alexis found did you see that, Sheridan? Apparently there is a trick to it.
Yeah, it popped up now.
Yeah.
What is it?
What she's saying is that she exited the full screen and then she came back to it and found the poll hidden behind that thing.
When you exit full screen, next to the share screen icon, there's one that says polls. You just click on it and the poll should pop up.
I just tried it and I still don't see anything.
Okay. It's okay. Hopefully you're following the questions though. And I'm going to post these things on Canvas anyway. You'll have more to it. Okay, this is just basically a snapshot so that since we're together, we have an understanding of how this thing is working. And but on your own, you will be trying to answer these questions and also at the same time review the book. And if you still have any questions, please don't hesitate to ask. Okay. I posted 4 questions for you, Sheridan. Hopefully you were able to. You answered one of them. Okay, 2.5 minutes. Okay, 4 minutes. Question 4, guys, you have to remember that this is false, not true. Okay. Two people locked in their answers. Okay. In about 10 seconds, maybe, should finish this. Let's get everybody, as many people as possible in. 5 seconds. Okay. Okay, so the polling is over. And let me share with you, there is one of them that seems to be consensus on it, everybody. Let's try to get to them, okay? Let me share the results in here. So the first one seems to everybody nailed it down. That is the scientist who worked out the mathematics to unify electricity, magnetism, and light is Maxwell, of course. Okay, that's good. There is no confusion about that one. Which of the following statements about the nucleus of the typical atom, such as carbon, is false? Okay, some of these questions are tricky. So when you're trying to do the exam later on, you have to be paying attention to what's going on with this question. So sometimes it's true, sometimes it's false. You have to really read the question correctly. So it says, The nucleus has an overall positive charge. This is true, so this cannot be the correct answer. So the correct answer is the false one. So you have to basically kind of, the nucleus takes up a very small amount of space compared to the entire atom. That's what the Rutherford experiment, guys, if you guys remember, most of the alpha particles go unimpeded. They don't bump into the gold nucleus, basically the nucleus of the gold atom. So they go straight through. So this is actually a true statement. It's not false. The nucleus contains both protons and neutrons. That is actually true. So it cannot be the correct answer. Okay. The nucleus contains most of the mass of the atom. That is actually true. So it cannot be the correct answer. The correct answer, the one that is false, is the nucleus repels electrons which move around it. This is not true. The nucleus does not repel electrons. Actually, the electrons are negatively charged and the nucleus is positively charged, so it cannot repel them. This is false, therefore this is true. You guys understand that? This is the correct answer, because we're after the false statement in here. And the false statement is this one. The nucleus repels the electrons which move around it. So the correct answer is this one, because that's the wrong one. You guys understand the psychology of this examination? Sometimes they work backwards. Okay? Now, in the 19th century, it became clear that magnetism was not separate force, but was always produced by the action of, most of you got this one correct, and that is true. The currents, basically, produce magnetism, okay? So the others, they are not correct. Nature presented us with some things that electricity and magnetism are produced by charges. Electricity is by charges by themselves, whether moving or not, and magnetism, and they have to be in motion, in other words, current. Okay, which of the following statements about the electromagnetic radiation is false? Again, this is one of those things you have to find. The correct answer is the false one, not the correct one. So you have to make sure that everything is correct except this one. It always spreads out of the speed of light. So this is true. So it can't be false. It is given off by all objects that are not at temperature or absolute zero. This is true. Only an object that is at absolute zero should not give off EM radiation. It is typically produced when charged particles oscillate, which is true. Different waves of electromagnetic radiation differ in their wavelength of frequency. So that is actually true. The radiation consists of tiny charged particles given off by the nuclei. This seems to be a tricky question for you guys. The correct answer is the last one. The last one actually is a false statement. And since we're looking for a false statement, this is the correct answer. The radiation consists of tiny charged particles given off by the nuclei of atoms. This is not true at all. The electromagnetic radiation is not a particle at all. It's a wave. Even in the case when it's a photon, the photon itself does not have a charge. So if you assume that the particles of light are called photons, these photons do not have a charge. So the correct answer is the last one, and the last one is the false statement. All of the other statements are correct. And so they are not the ones that we're looking for. Basically, we're looking for something that is wrong. And the wrong thing is the last one in here. Is this clear to everybody? Hopefully you understand this part. The moral of this practice actually is very important. When you're doing the exam, you have to read the question. Sometimes the question can be tricky, like this one. You're looking for the false statement, not the true statement, to answer it as being the correct answer. Okay? Question 5. The light which allows you to see this very interesting screen, the screen that we're looking at, is made up of waves. In this wave, the distance between crest and crest is called. So we're looking for a distance. And the distance cannot be a speed. And I'm glad nobody picked up that one. The amplitude is how up and down basically this thing goes the wave, so we don't care for that. And the last answer doesn't make sense. You can't fool me. This wave, the distance between crests is 0. That doesn't make sense. So really the choice is between a wavelength and frequency. Most of you get the correct answer, wavelength, because the distance is the length. So the wavelength, how long is the wave? So that builds into the answer itself, actually. So the correct answer is what most of you got is correct. How fast do electromagnetic waves travel? It's not the speed of sound. It's not the speed of a charge. Because charges, they move a lot slower, actually. And at different speeds, depending on that. I'm glad nobody picked up the last two answers, which don't make sense at all. So the correct answer is actually what most of you got, which is the speed of light. Because light actually is an electromagnetic wave. Okay. We have two waves of light, A and B. Wave A has higher frequency than wave B. Then wave B must have, it is not the higher speed or lower speed. Both of them are traveling with the same speed because both of them are light, okay? So these two answers cannot be correct. The choice are either longer wavelengths or shorter wavelengths. But because the speed, they have the same speed, and the frequency are different, one of them has higher frequency than the other one, then they have different they have different wavelengths. One of them is longer than the other one. Basically, the faster the frequency, the shorter the wavelength. So in this case, wave A has higher frequency than B, then B, because frequency of B is less, then B must be longer wavelength, okay? So, I mean, it was like kind of 50-50, but the correct answer is the ones who got most of it correct. Most of you got this one correct at this point. So it's the longer wavelength because B has less frequency than A. Therefore, B has longer wavelength. Okay. In chapter 5, discusses that light sometimes acts like a photon. What is a photon? It's not a particle. It's not a charge. It doesn't have a charge at all. So you can't say correct. Answer A is not correct. It doesn't have electric charge. Kind of magnetic substance found in reflective minerals. That is, I don't know what that statement means at all. Okay. The cells contain packet of EM energy. That is correct. So most of you get this one correct. That's good. After a nice dinner around the campfire on a camping trip, you and your friend decide to get away from the campfire to observe stars. As you get further and further away, you see the brightness of the fire increase with distance. That's not correct. When you move away from a light source, its intensity actually starts to decrease. It should not start to increase. Most of you got this one correct, which is decrease with distance. It should not remain the same. It should not remain the same. If some of you change it, choose it, please make sure that this is something that has to do with the intensity actually drops 1 over distance squared. This is one of the things we discussed when we were in face-to-face class. Or was it not? No, we discussed this in here. Chapter 5, we discussed this in here. Consider a radio wave from the transmitter of your favorite radio station which has just reached the antenna of the radio in your room. Which of the following statements about this radio wave is correct? It has a frequency close to the highest possible frequency for EM waves. That is not correct. The highest frequency possible is the gamma rays, and gamma rays are not used for telecommunications at all, whether for radio or TV or for cell phones or anything like that. Gamma rays are super energetic and they cannot carry with them this much high frequencies. So it's actually it's not possible to use them for telecommunication, at least in our technology, because you have to receive them first, and they're so energetic that it's very difficult to use them for that. Besides, they don't travel very far. I mean, they're very short wavelengths. They don't travel very far at all if you use them for telecommunication. It travels between the transmitter and your radio antenna at the speed of sound. That is not correct, because this is an electromagnetic wave, so it travels with the speed of light. Its wavelength is much longer, so we're looking for a correct statement now. Both of these two are not correct. Its wavelength is much longer than the wavelength of light you see reflected from the page of the screen. That is actually correct, because the wavelength of telecommunication frequencies are a very long wavelength compared to the visible light. So this statement is correct. So this is the correct answer. And the waves, what is it? The wave was originally produced by electrons that were not moving at rest inside transmitter. That's not correct. In order to produce EM waves, in order to transmit the signal, you have to have actually charges moving up and down, at least on an antenna. And the reason that it could reach your radio is because all of the space is filled with a medium called the ether in which electromagnetic waves can vibrate. This is something that people initially thought it's possible, and they did experiments. Actually, Michelson and Morley did an experiment on that, and Einstein later on confirmed that the fact that this is not correct setting at all. We don't have an ether, okay? Okay, I hope that this exercises, I have a few actually more of this, but I think we're short on time right now. I don't think that we can start another one. You want to do a quick one with 5 questions? Still have about, yeah, somebody agrees, okay. Okay, I don't want this in here. Let me put another one. Which one has the shorter? I don't remember. Was it chapter 4 maybe? Chapter 6 has a lot of questions in it. I don't think that we can do this. Yeah, chapter 4 has another set of questions, and there are only 5 questions, so we can spend about a few minutes on it. So I'm going to launch it again. And tell me quickly if you guys see it or not, because it's supposed to be live. Okay, somebody is looking at it. Very good. Because this is a shorter quiz than the first 2, so we're going to make this one actually 3 minutes only. There's only 5 questions. I didn't forget your share, then. Okay, I'm going to get you some questions in here.
Thank you.
Okay. One person locked in the answer. "30 seconds left for this quiz." "10 seconds." 5. We're going to finish it right now. Okay. I still have few more people, please. Okay. Okay, we're done. Okay. Let's go through these questions again. Which of the following is an important part of the reason it is hotter in summer in North America than in winter? The Earth is closer to the sun. That is not the reason. The distance usually is not the reason. The sun's rays hit the Earth Okay. More direct in the summer and spread out less, so that's really white is the correct answer. Okay, question 2. In what location on Earth could an eager math student not use her solar-powered calculator at any time at all during the course of a day in June? Is it really the North Pole or the South Pole? I mean, those are the only two correct. One of them is correct answer. We're talking in June now. I want you guys to tell me, because it seems like almost of you guys split 50-50, and the majority of you guys think it's the North Pole. Should it be the North Pole or the South Pole? She cannot use her calculator in the summer, basically. What do you guys think?
South Pole.
South Pole should be the correct answer, yes. I know it was kind of 50-50. If it was in the winter, she cannot use it in the North Pole because it's all dark. She cannot get the sun at all. Okay. Question 3. Some college students decide to form a secret society that would meet each year after graduation at a time when the day and night were the same length. Which of the following would be a time they could meet? So they graduated college and they decided every year we're going to be meeting from now on when the day and the night are going to be at the same length. Cannot be January, the day is shorter than the night. Cannot be December 22nd, that's actually very same thing. It cannot be June 22nd because the day is a lot longer than the night. So the correct answer is September 22nd. I think that's the 22nd. That's the fall equinox. Okay, and that's where most of you get that answer. And an eccentric billionaire wants to build a mansion and located on Earth where the effect of season is least pronounced, where summer. So this seems like 100% got this one correct. So he wants to have the least season changes possible. So he's got to go into the equator where the sun moves in and out of basically. Most of the time the weather doesn't change much. None of you guys chose Moreno Valley for some reason. So this billionaire cannot live next to us. Okay. If there really were a Santa Claus at the North Pole, what would the cycle of seasons look like for him and Mrs. Claus? 6 months of light followed by 6 months of darkness, or at least dark night. So that's twilight. So that's the correct answer. Okay. So I'm going to share with you guys I'm going to post on Canvas a lot of this stuff in here, and hoping that you guys have time to review this thing. And the focus now is actually on the exam more than anything else. Don't forget you also have a project that is due to finish it. And if you have any questions, do not hesitate to ask, and let's get this thing done. Any questions for me before we end the meeting? So it's going to be posted tonight. Hopefully after I have another classes also later on tonight. If I don't get around doing it tonight, it's going to be tomorrow morning. You have a good rest of the day, and please stay safe.
That fill sheet is already up on Canvas.
I'm sorry?
That the sheet with all the blank spaces to write in.
The one, oh, okay, the fillable form?
Yeah, it's already on there. I already downloaded it.
Okay, very good. Okay, very good. For some reason I thought it was. Okay, thank you guys. And have a good rest of the day, and please stay safe, okay? Thank you, Alexis.
Thank you.
Okay, bye.